In this video, we are going to program the Euclidean algorithm, which is a way to find the greatest common denominator between two different numbers, a and b. So our function is going to have the header GCD equals Euclid, and our inputs are a and b, so two different integers. And the Euclidean algorithm for finding the greatest common denominator of a and b is as follows. So if a is less than b, exchange a and b. So we always want a to be the higher number. We're then going to divide a by b and get the remainder r. If r is equal to 0, b is the greatest common denominator of a and b, and we can stop the loop. Good to go. If r is not equal to 0, we're going to replace a by b and replace a with b and replace b with r, and repeat steps 2 and 3. It's a lot, so I also made a flow chart for us right here. So we're going to start. Our inputs are a and b. We're going to calculate the remainder, r, of a and b. Then we're going to say, is r equal to 0? If yes, b is the greatest common denominator. If no, replace a with b, replace b with r, calculate the remainder, r, of a divided by b. Is r equal to 0? And so on, and keep going until r is equal to 0, and then we're here. At first glance, this may look like you want to use an if statement. But because we are doing this until this is true, so this is the start of a loop, you can see our arrow coming back here. This is our logical statement for our while loop. So it's a common mistake to try to use an if statement instead of a while loop. Here we're going to use a while loop. And the if statement, or the logical statement, is part of the while loop. So we don't need to do a loop and an if statement, just going to do a while loop. So we're going to do this while r is not equal to 0. So let's get started. Heading to MATLAB, all the results from our previous example, creating a new function. A and b are our inputs, and we're going to start by calculating the remainder. Luckily, we can calculate the remainder using the remainder function in MATLAB. So if we go help rem, we see that that is the remainder. We can also calculate the remainder by dividing a divided by b, rounding that down, and then subtracting that from a, which I'll write that out. I know that was a lot. First, I forgot we have to make sure a is greater than b. So sometimes somebody might enter a lower number for a than b. And the way that our algorithm works, it assumes that a is always the higher number. So if a is less than b, this is when we have an error. So we need to replace a with b, so swap them. Remember, to swap something, we can't just say a equals b, b equals a, because that by the time that you get to the second line, they're both going to be the same number. So first, let's create some temporary variable equals a, and then we can say a equals b, and then b equals whatever we stored in that temporary variable, which is a. Now we're going to calculate the remainder of a divided by b. I'm going to call that capital R equals rem a comma b. So that's the syntax of our how you use the function rem to find the remainder. A comma b means the remainder of a divided by b. The other way that I said we could calculate the remainder would be floor, so that floor rounds down, a divided by b, and it would be a minus that. So this is how many times b actually fits into a evenly. Oh, and it should be floor times a times b. So that's how many times we can add b up without being greater than a, and then the difference is the remainder. But like I said, it's built in, so we're just going to use that. So we want to do this while the remainder is not equal to 0. So while the remainder is not equal to 0, we are going to look back at our algorithm. So we're going to replace a with b. So we're going to say a equals b and b equals r. And then we're going to do it all over again. So a equals b, b equals r. This is replace a with b, replace b with r, and calculate the remainder. Of our new a divided by b. We can use that same line. You'll find this is common to, you have to define or calculate what's in our logical statement before the while loop. And then remember, it also has to change within the while loop. We don't want to have an infinite loop here where we go on forever and ever and ever and ever. Let's check if this works. Oh, 1 second. I was just about to type it and then realized that we had an orange error. So when I hover over this, it says function return value might be unset. So our little orange line is under GCD. If I click on that, I see the only place that I have this variable in this function is here as an output. So that means I need to define it. It needs to be on the left-hand side of an equal sign somewhere in my code that says GCD is equal to, and it is equal to R. B. Hold on. B. It is equal to B. There's different ways that you can do Euclid's algorithm in the exact order of the steps you choose, but the way that we did it, if you look back at our flowchart, it's B. So saving that, let's do Euclid. Let's try one first that we know, 44 and 4. So that should be 4. Let's try 45 and 30. So that one should be 15. Great. It's always, I think, important to do one where this one would not go into the while loop, because 44 is evenly divisible by 4. So if we look back at our code, this would be 0. So we would never enter our while loop. I think it's important to, when we're testing our code, try to test that scenario as well as trying to test one that goes into our while loop. Because if we just test the one that goes here and then think our code's good, our while loop could be completely wrong and we wouldn't pick that up. Whereas if it works in our while loop but doesn't work in the first scenario, you might also have an error. So it's important to check both. Let's just do one more that I don't know. 1. I saw that coming. That one is 5. And so on. So you can just keep checking different ones. And as I had said on the top of the page, there are multiple ways to do this. So if you did this and your code looks different than this, that's okay. As long as you still got the same answers as me, it's right, whether or not it looks exactly like my code.